Okay. We'll go forward. Now, our next and last presentation for the day is writer recognition by computer vision. This is discussing the SIFT algorithm. It was intended to be presented by Jeff Woodard from the MITRE Corp, but he unfortunately couldn't be here today. So Dr. Chris Sunders, also from the MITRE Corp and now at South Dakota State University, will be presenting on his behalf. And please bear with us. Chris just got the slides last night, so he'll do his best to explain them, but be easy on him.
Please be easy. All right. So I have my notes here that Mark had just sent to me. And so I think the first and most important thing to say is that we're low on disk space.
Hopefully we'll make it.
Oops. Let me go back. So first I have to say that Mark Lancaster is at the Central Intelligence Agency, and he's a program manager for this work there. All right. So this project, I believe, started in 2008 or 2009, and the main purpose of this project was to develop a completely open source method to assist in getting researchers, computer science and statistical researchers involved in handwriting research. So the choice of the algorithms that were used were common in the science and engineering field, especially the computer vision world. They do not correspond to anything that would commonly be used by forensic handwriting examiners. And again, these choices were driven more by a systems engineering point of view than any tradition of handwriting identification. To the best of our knowledge, all of the methods are in the public domain. They're not geared towards any specific language, and there is no segmentation of the handwritten document into the individual components. All right. So let me go ahead and talk about this. This is the methods that are based on this are focused on extracting features from a document. Basically, it'll take a handwritten document, it'll view it as an image file, and then break the image file up into individual components, and then start to look at local features in the image file, much as you would do if you're looking at a digital image or doing matching, looking for shapes or whatnot in a computer vision application. A lot of the approaches that are being driven by this arose out of natural language processing and natural language processing, mainly focusing on latent variable approaches to try to make these categorical distributions be more flexible to be able to characterize the writing profiles that are going on. We've done some basic experiments in both Arabic and Dutch, and the features, which is the hard part in most of these applications, is figuring out the features that you can use that are reasonable to get your feet off the ground to start looking at these methods from a statistical point of view to build up the handwriting and statistical pattern recognition methodologies. The features that Jeff and Mark had chosen are based off of the scale invariant feature transforms. And so what will happen is that you'll see the first S and the second S are just rotation and scale transforms of each other. And you'll get a very similar descriptor for these two algorithms, mainly the slight change in the first component of the descriptor. Whereas if you move to the last one, in the descriptor, it'll actually be a radically different type of characterization. The method that was based on this was developed by Lowe, and it's using a scale. It basically will shrink the images and blow the images up, and he refers to them as octaves. I do not understand why. Hopefully, I know there's some wonderful computer scientists in the audience, so if they can answer that would be wonderful. But they then go and they use a difference of Gaussian representations, almost like a Fourier type of transform, to find extremums in the image space to be able to do the quantification. So this is what you end up getting. You'll go through and you'll take the actual document, you'll apply the SIFT algorithm to it, and you'll find these landmarks, these local features. And then you'll record the characteristics of them, such as spacings for some of these, shapes, and basically directions of intensities. You'll then and so this is the markup of the same document here. What'll happen is that you'll then use a codebook approach, much as has been mentioned in the last talk. You'll end up using a k-means clustering approach or any type of vector quantization approach, and then that'll allow you to encode in a codebook a distribution of these feature vectors in these feature vectors. And so you'll then compare the two histograms. And if the two histograms are radically different, that's indicative of the two documents having a different source or being dissimilar. So these are some of the code books that you'll tend to see, or you'll tend to see in the context of the SIFT in terms of these algorithms. These are, I believe these are brought up. So for each one of these is a single cluster in a code book. So these are the ink blobs that have been assigned to the first code word in this clustering algorithm. And there's actually there would be a large number of these code words in a given code book. I think, if I remember correctly, we had explored up to about 250, but we've gone we tend to use about 250 code words. What happens is by taking these images and then mapping it back to this bag of words, the data structure from a statistical point of view starts to look very similar to what you see in natural language processing. And so what will happen is there's this n-gram approach in natural language processing, and so you'll map, and so we'll start to use the statistical methods associated with that. One of the common ways is to do what's called a bag of words. So we'll take these blocks of words, record their distribution across the block of words into this histogram. And this is basically a pretty good flow chart of what I was trying to explain on the last slide in jumping the gun. So we'll first have a learning phase where we'll build up the bag of words. We'll then take a question document where its class is unknown. Do the same, build up the bag of words for the question document, and then do the comparison for all of the classes, which in this case is usually writers. So each class is distinct by a distinct writer. We'll find the class with the closest similarity score, which usually is going to be some type of Euclidean distance, and then we'll assign the unknown document to that class. So it's a relatively simple classifier. I'm sorry, I have no idea what Mark and Jeff are trying to say on the slide.
Short on time.
Good. So in the interest of moving along promptly, let's skip the slide. Yeah. So one of the early methods that was being used in this was actually this latent semantic analysis. Being a statistician, I tend to think that computer scientists rename everything. So I would say that this is a simple version where they've gone through and they're looking at a finite mixture of multinomial distributions, and then using that and to gain a more flexible modeling system to be able to represent the histograms that show up in this bag of words problem. And so, but it has some nice interpretations. Sometimes it'll give some incredibly nice graphics. But in the end, it's just a slightly more flexible way of doing the modeling for each one of the classes. And I'm sure if Jeff and Mark are listening, they're throwing something at the screen right now for me saying this.
So, right for not being here.
So, all right. And actually, if they are listening, please comment if I'm messing up anything in the Twitter feed.
Nothing yet.
Okay, good. Anyway, so this is the latent semantic analysis with the image views. There's a good you'll see the words. You can think about the latent topics as, oh, I need to stay near the mic, don't I? I'm getting excited now. All right. So you'll have the latent topic, which is in a way acting as a clustering approach for these words to get an idea of maybe writing style, and is what Jeff would say, and I would use slightly bigger quotes on that one. But it's a way of doing the encoding. One of the approaches, the latent semantic analysis will give us induce basically a probabilistic ranking of the documents based on this writing profile that's characteristic for each one of the writers, and this allows us to build up an identification system based on this ranking. We had gone through and done some testing on this. We had gone back and compared this to, I believe this is Cat and Frankie's, Barlusci's, and Shoemaker's data set, or analysis from 2012. If Katrin's here, I think this is the most recent one where they've looked at this data set. Is that right? The 2012? Yep. And so we had gotten that data set and done a comparison with it. The latent semantic analysis approach. Let me see here. Not sure what's going on with the slides, but anyway, here's the actual one. The latent semantic analysis, which is the PLSA, that was achieving a rank 1 error rate for close set identification. Close set identification, in my opinion, tends to be the easiest of the identification methods. With a codebook size of 512, that tends to give a rank 1 error rate of about 11.8%. When we've applied, there's a secondary method that was developed using a spatial pyramid approach, which increases the complexity of the codebook generation, and then uses a single nearest neighbor classifier. That was able to get down to a 4.4% accuracy. And it also was very important for this, is actually significantly sped up the computational time to do a complete cross-validation on this data set. The PLSA we only did a 10-fold cross-validation, which was still quite intense in terms of computational time. All right, so in conclusion, there's a fully automated method for doing a handwriter recognition. This is based on general computer vision principles based off the SIFT algorithm, the scale invariant feature transform. It seems to perform reasonable in the Dutch and Arabic and other languages, and there's little or no human supervision. And then, to the best of our knowledge, all of these algorithms are in the public domain. And there is a lot of work that remains to be done on this. And if you have any questions, I will do my best to answer them. I make no promises, though. So.
Question in the front.
Hey, Chris. I'm not sure this is an easy one, maybe not. Just on towards the end where you had the latent topic, and you mentioned that was used to generate the cluster. Is that in what particular way related to the codebook? Is that a level in the codebook? Or
so what will happen is that you'll get your batch of writers coming in. Are you familiar with mixture analysis, finite mixture analysis? It's basically doing a finite mixture analysis. So you can think of it as a soft clustering of the writing profiles that are going on. So you've now used the codebook to quantify the handwriting samples. And so now, and you can think of the way that these were originally thought of is the codebook. You'll get this histogram, which is thought of as a mixture of multinomial distributions. And so now this is acting, the latent variable is acting as a different type of cluster of the writers. Okay. So you okay on that? Okay.
Any other questions? Okay, let's thank Chris.
So no complaints.
No complaints. And no online complaints, which is a good thing. So at this time, before you run out the door, I'm just going to see if there were any unanswered questions. I know I put a few people off who wanted to ask questions of our speakers. So and if you could just identify which speaker first, and then we can get them to get a microphone as well. And we have another one over there as well.
Yeah, this is a question for you, Joanne.
Oh, well, that'll be easy.
So stay there.
Okay.
So we've heard several automated systems, about 5 or 6 of them. We've just heard them. And, you know, they each of them did experiments. They did it on their own data. They did it separately. The question is, how do we compare them? How do we know what's good? How do we know what's bad? How do we know which of the techniques is more successful than others? And you mentioned, and at NIST, we do evaluations for different technologies in other areas, like in fingerprints, in face, in iris, and in language, and in video, and areas like that. You mentioned that you do something, that you're doing something like that in the FBI in the handwriting area.
I would like to clarify.
And
I didn't say we were doing. I said it should be done.
Oh, okay. So we volunteer to do that for you if you can get money for us.
That's the big key.
Because we have experience in doing this in at least 6 or 7 different areas.
Right.
But it's really something that's missing here because, you know, there were good ideas in all of the systems presented, but how do we know which are the better ideas and which ones have strengths and where are the weaknesses?
Right. Okay. So I'll start off by saying that a number of years ago, I actually proposed this internally to the Biometric Center of Excellence, who should have been watching, but DOJ blocked their signal, so they will see this on rerun. Of course, it's a matter of funding. We're very aware of the nice work that NIST has done in the fingerprint challenges across the APHIS vendors. We've only really, in the last few years, gotten to the point that there are enough systems and approaches to do a grand challenge, such as the one you do for fingerprints. And I think it's time. I think it's time that the same data set. I see Katrin has her hand up in the back. I know that the NFI has done some work in this area with signatures in particular, and I'll let her speak if Kristen can get a microphone over to her. But yeah, I do think it's time. We actually did a data collection of writers through our Biometric Center of Excellence. We have 1,000 samples. I won't go into how we selected the people or what they wrote or whatever. But the intent was part of that data set was going to be sequestered and held out for doing some of these challenges. So the intent is to get there. It is a matter of funding, and it's a matter of now getting the community to get the algorithms together to a non-competitive place like NIST to do an evaluation. But yeah, so if anybody's out there and has some funding, although I'm not allowed to lobby, this is a good thing. No, I'm not sure that I can do that. But NIST, since they don't regulate anyone, they can get lots of money. That's what JP tells me. So maybe he can do it. So Katrin did have a comment in the back regarding this.
Just to mention, we started in particular in the document analysis community where Dr. Shrihari and I met before with competitions on signatures in 2007. And what was very interesting there is that we got also a lot of submissions from commercial systems originating from the commercials like postal systems and so on. And they score relatively high. The challenge I see is to bring the communities together. Mm-hmm. So the research committee, document analysis committee that run those competitions, and the pure hardcore forensics community. And to mention, I'm not paid, but there's a conference in August, Harry, ICTA 2013, held in Maryland, organizer David Derman, and maybe you use the chance and get in touch. And some of our colleagues are also organizing competitions there. Though, bring the communities together. Do not always talk. So for 10 years, I have been always attending 2 conferences, and never the one or the other conference committee knew the other group. And
Right.
it's a pity to see. So you can go much faster and develop if you communicate. Thank you.
Thank you. Actually, while you still have the microphone, I did want to ask a question of you regarding script. I was aware of script, but in the summer I was over at NFI, and it appeared to me that they weren't using it. So maybe I'm wrong on that. Did they stop using it? Do you know?
I know that script development started. Your battery is empty. Script development was launched 1949, and there was a comparative study between script and fish done by Lambert Shoemaker in 2000, published 2000. And at this time already, script was dying out because it was not maintained anymore. But we know the people, so the people are alive, the key developers are alive. So bring them together and get their brains together and work. And I had a question to Siemens. I mean, they are the most professional in system design, and they use voting systems to combine OCR systems. Why not using voting systems to combine rider identification systems? Plug-in principle. So.
Yeah, we use this technique already, and I've shown that we are integrating some completely different feature vectors, and it's easy to plug in another engine, for example, which has a standard interface XML.
Okay, thank you. Anyone else have burning questions?
My question is for Katrin also. You showed a slide where there were dark pen marks. They looked very much like what I'm familiar with as gooping of a pen, where the pen takes a hard angle and then deposits a ballpoint pen, deposits a blurb of ink.
Spin, you have the typical
And
ink drop.
I'm wondering how you are, or if you are, I was confused, are you distinguishing between the ballpoint pen-made goops, or are you saying that they are goops caused by an action of the writer? And how do you determine which is which and what is going on with all that, please?
Yes, the study I showed, the very at the end where we're always flipping through my slides. Sorry for this. So there was one study, and one study was only that those pen drops are reproducible. If I apply the same writing type, velocity, everything done by the robot. So the pen phenomena are predictable. They are always in the same position. They are reproducible. You can rely on them because of the dynamics of the writing process and the different spin you get in the sphere in the ballpoint pen, for example. And standard, yes, sorry for the limitation. I mean, this is the beginning. We have all the same problem.
Are you saying it is because of the pen or because of the writer?
It's the combination of both. I don't say. So if, and it depends on the ink type. If you use a ballpoint pen with viscose ink, then, and the particular writing dynamics, then you have it. And if you write multiple times with the same style, the pen phenomena are to a, what they had 69% likelihood at the same position.
Peter, we have a question. Unless that's a follow-on, we have another question here. Okay.
Actually, one quick follow-on to that before I get to the one I actually had. Is it an issue with the robotic writer in that you had reduced degrees of freedom, therefore you saw consistent deposition?
Well, what do you have? We started, there was the study where I started on was originally also from 1977.
Yeah.
Also, it was Humboldt University in East Germany, and they did this so-called densitron, and the densitron was heavily criticized. Is it reproducible or not? And then I said, okay, it looks like it is reproducible, but someone needs to prove it. How can I prove it? I cannot prove it if I have another human writing. So I need to have a systematic way to repeat the same writing movement multiple times with different pens. So we had 20 different pens, 20 different ballpoint pens, same movement, same phenomena, at the same position.
Back to the Holiday Inn. What's it?
So the next question that I actually had was for Edith Marker Don relating to Flash ID. And I was curious, the idea of graphenes being...
I'm sorry to interrupt. JP was mentioning that there might be the shuttle to the hotel leaving at 5 from the front. So if anyone needs the shuttle, you may need to make that decision. So 5:30?
5 or 5? 2.
It'll leave at 5:30. That's what Clinton said. All right. Sorry.
Okay.
This is quick. Basically, the idea of graphemes, I can get the idea of a graphemic element being driven by handwriting habit. So for natural writing, I have no particular, it's not a surprise to me the system will work really well. Have you tested it with distorted or unnatural writings, disguised writings, simulations, anything of that sort, where it's no longer a habitual movement?
Actually, we have. It was a controlled experiment by our IC sponsor who had writing generated by a forensic document examiner. And they did 5 different styles. And what we found is, imagine if you have 100 characters of natural writing, you get the full benefit of 100 characters. In the various forms of disguise, you would get the benefit of something less, like maybe half or so. So people always reverted at some point to their natural writing.
Okay. We're going to go ahead and wrap.